In this example, we are going to practice area under the curve again. The difference being we have the notation for the area under the curve as a definite integral. So for part A, we're looking at the integral from -1 to 0 of f of x. So this is y equals f of x. And so that means we're really concentrating on this area here from -1 to 0. And we see that we have two regions basically. That we have one triangle that with base 1 and height 2. And then we have this rectangle of width 1 and height 2. So that ends up being 3 for my answer for part A. For part B, we have the integral from 0 to 2. This is 1, this is 4, see it, you can't really see it, and that is 6. And we are looking at from the integral from 0 to 2, so this is for part B. And we have a triangle, 1/2 times base is 2, and height is 2, for a grand total of 2 as this area. Now this is a typo. I wanted this actually to be from 2 to 4, and I actually want this to be from 0 to 6. From 2 to 4, we are looking at the area of this region right here. And what we want to remember is the area of a circle, a full circle, the area is pi r squared. Our radius for this circle is 2. So the area of the full circle would be pi times 2 squared, or 4 pi. But from 2 to 4, we're only looking at the quarter circle. So the area would be 4 pi divided by 4, or pi. And then the fact that it's below the x-axis gives us this answer is -pi. Now the integral from 0 to 4, we're looking at area between, under the curve, in other words, between the curve and the x-axis. So we have this area we already calculated as 2. This area we already calculated as -pi. So we get 2 minus pi as the answer for part D. Now for part 6, or part E, going from 0 to 6, we are now looking at all of this, and we would have, now we have the half circle below would be -2 pi, and we still have this above, so we have 2 minus 2 pi.